Hello and welcome to this GarrettCom training presentation on demonstrating a broadcast storm. Okay, so in the previous videos I talked about the effect of having redundant links in your network without spanning tree protocol or some variant of spanning tree to manage those redundant links. And the effect is that it causes a broadcast storm, also known as a switching loop. What I want to do is show you the effect of that now. So if I show you the network, we've got a couple of small units, ES42s, and these are basically unmanaged switches. They don't have any spanning tree capability whatsoever. So what I was going to do is connect these two together, ping the final switch at the back here, and then connect a redundant link and show you that the switches lock up. And as soon as we disconnect the redundant link, the switches return to normal operation. And this is a perfectly normal standard part of Ethernet networks, and that's why we have spanning tree protocol. It's also why we have a protocol called S-Ring, which is GarrettCom's proprietary protocol used to manage redundant links in large rings, primarily of unmanaged switches. So these switches can have redundancy when you use S-Ring as well, and S-Ring will be covered in another video later. Okay, so let's get this set up, and I'll be back with you in a second. Okay, so I've connected the cables and we have my PC connected here to this switch. We're going to go to this switch from my PC via this connection here to this second switch, then from the second switch via this connection here to the third switch, which we'll be pinging. So we're going to ping from my PC, switch 1, switch 2, and then finally the third switch at the back. As you can see, there's only one link between each switch, there's no redundancy, so there should be no problems with broadcast storms. So let's fire up the command prompt and let's get a ping going. Okay, so I've started a ping from the command line. We're pinging the camera at the moment. I don't know why I decided to pick that IP address. What I need to pick is not 199 but number 2 minus T, which is the switch, and we can get there just fine. So we're going back to the topology. We're pinging from my computer this switch through this switch, and finally we're pinging this switch at the back, and that's the IP address of that switch. That's where we're going. Okay, so what we're going to do now is we're going to connect a redundant link between the two. Here's a cable to do that, and we'll see what happens. So I'm connecting in the first switch, connecting a redundant link back to the second, and we'll see what happens to the pings. Things seem to be working okay so far. Okay, basically it's a broadcast storm, so you need to have some broadcast traffic on the network before it happens. So it's not immediate, it's not necessarily... Oh, there we are, we can see straight away. Well, not straight away, after a few seconds. All it took is a few seconds before a broadcast naturally comes to the network, and as soon as it does, the network starts to lock up and you can see the camera's locked up, because the camera's connected to the same network as well. If you could actually see the LEDs, it's a shame. I'll see if I can't find a way to get that on the camera, because they are blinking away like crazy. So let me just think for a second and see how I can do that. Okay, success. I can see the cameras, we disconnected the camera from the network, the IP cameras come back up. You saw how it locked up because the switches that it was using to communicate, all they were doing is processing the broadcast traffic. They're still working, they're just doing what they're supposed to do, which is process broadcasts, but that's all they're doing when there's a broadcast storm in effect. And you can see the LEDs are blinking away like crazy. So if you see the LEDs blinking away like crazy, the switch network is locked up and you've got redundant links there. Chances are it's a broadcast storm, but to be honest, this is a lab demonstration. In reality, you'll be using spanning tree or some variant of spanning tree protocol in your network, and this type of situation should and normally does never occur. It's almost a question of very poor design if this happens, and it shouldn't happen, and we've got protocols and we've got features to prevent this problem from happening. But I just wanted to show you the purpose behind spanning tree protocol, and that's it. So if we disconnect the redundant link, we take those out, the switches calm down straight away, and if I plug in the PC back in here and go back to the ping, eventually it should come back in. So we can see here all of this destination host unreachable, yada yada yada. Eventually the ping will return when it finally comes back to life. Hopefully if I connected it correctly. Okay, I haven't actually connected it correctly. I disconnected the second switch as well. And if we go back to the, there we are, it's back up. So we connect the, I won't show you again, but you can see it. You can see basically the switch will stop forwarding traffic, the switch LEDs will start blinking away like crazy, and all that's happening is that the switches are just too busy processing broadcasts to do their proper job. And that's a broadcast storm. So I hope this has been interesting, I hope it's been helpful for you, and on behalf of GarrettCom, I'd like to thank you for your time. Goodbye.